Alright, so bismillah. Okay, double into apa dia? Saya dengar ada macam suara nak ni. Kelvin dengan Fatin Iwan ni boleh tolong mute. Alright, thank you. Okay, double integral over a rectangular region. Apa maksud double integral? Okay, sedikit review, a little bit of review. Review from your calculus 1. Calculus 1 tu maksudnya MTH 3100. Okay, kalau ingat lagi, dan saya harap awak ingat, okay, kalau kita ada a curve, let's say this is fx, and then kita nak cari the area under this region, fx. Apa kita buat? So we divide into equal rectangle. Kita bahagikan kepada beberapa segi empat yang sama. Buatlah sampai ke yang terakhir kat sini. Bengkok. Okay. So kita kata apa? So kita kata ni adalah segi empat. Maybe like that. Kemungkinan macam itulah. Right end or left end. So kita kata the area data A untuk apa ni, untuk one rectangle, let's say this is area N. Kita nak ambil area yang terakhir. Sorry, tak nak. Saya nak ambil area yang pertama dulu. So let's say this is delta A, a small area of this rectangle, sama dengan fx of 0 at x star darab dengan delta x. Okay, so yang ni untuk satu area sahaja. Okay, dan delta A0 lah. And then kalau kita kira sampai apa? Sampai delta A of n. Let's say tak nak, sorry, saya tak nak start daripada kosong. Saya nak start the index from 1. Sebab ada sebab dia. Alright, and then sampai delta n kita akan dapat fx of n star delta x. Okay, so this is the area under the curve. Apa tu delta x? What is delta x? Tengok area kat sini. Apa tu delta x?
Differential.
Differential. Not there yet. Not there yet. So delta x is just the width. Kat sini. This is the delta x. Apa dia? Formula untuk area of rectangle is width times height. Ini yang kita belajar dekat sekolah rendah. So width times height. Apa ni? Lebar darab dengan tinggi ataupun tapak base times the height. Base dia adalah delta x and then height dia adalah f x at certain points, let's say x of 1, x star. Okay, kalau dalam kes ni, kalau saya ambil x star sebagai endpoint, so ni adalah left point. So saya boleh buat f ni, dia macam kat sini. So saya ambil kat sini. Okay, so yang dia punya length ni, dia punya height ni, di sini. And then this is the delta x. Benda yang mudah jadi, cuma kita expand your knowledge onto something else. Okay, sama macam ni. So area untuk rectangle yang kecil ni sahaja. Okay, so for every area, so for total area. So yang ni cuma apa ni, this is just review. Kalau siapa yang tak ingat boleh, so saya bagi peringatan lah sikit. So this is just a reminder for you. Okay, total area. So kita guna apa dia? Riemann sum from I from 1 until n fx of I star times delta x. Total area. Is this exact? Is it exact? Adakah area ni tepat maksud saya? Is it exactly the area under the curve?
No.
So dia tak, betul lah. Dia yang ni adalah, it's not exact, this is called approximate. Approximate area. Sebab apa? Sebab dia finite. Kita tahu bilangan dia. So this is finite. Total area of finite n. So untuk menjadikan, to make it exact, you need to take the limit. Limit n goes to infinity, and then I from 1 to n fx of I at any point. X star ni tak kisahlah kat mana, delta x. So yang ni adalah definition untuk apa? Definition untuk integral from A to B. So this is A to B. Sorry, lupa nak bagi dia punya ni. From A to B. From A to B, f of x dx. So yang ni definition untuk single integral. Satu integral. So definition untuk satu integral dia akan bagi apa dia? Area. So one variable, integration of one variable dia akan bagi area. Integration, double integration agak-agak dapat apa? Dia akan dapat volume. Okay, let's apply this information. So kita tahu information apa dia? Maksudnya apa? Kita bahagikan, you divide the region into several rectangles and then take the total amount of area. Same thing, if you want to put the similar definition, let's say you have other surface. Let's say this is a surface. Okay. Dan ni adalah dia punya coordinate. This is X and Y. And then Z ataupun FXY. Okay, saya nak tengok, I want to look at into a small rectangle kat sini dan saya nak project dia dekat XY plane. So kecil macam tu. Kalau saya buat, if I multiply, let's say this is the width is, this is dx, delta x, sorry, delta x. Yang ni adalah delta y. And then dia punya tinggi, the height is f x star and y star. So kalau saya buat macam ni, if I do like this, and then I multiply f x star y star times delta x times delta y, what's the value? What's the name of the output?
Volume.
volume, right? Sebab apa? Sebab volume is base area times height. Same thing. Benda yang sama. Yang ni apa dia? Height dia adalah, this is the height, h, and this is the base area. Nampak tak? So kalau saya, macam juga kalau saya bagikan, so kalau saya projected benda ni dekat x and y, this is projected. Project the region. Onto XY plane. So saya project the region. Okay. Dan saya akan dapat, let's say I projected into a rectangle. Tak sama. So this is X, this is Y. And then saya akan dapat several square or maybe another rectangle. It might be a square, it might not be a square. Like this. Okay, so yang ni pun, let's say this one is delta X, the same thing, delta X. So delta X throughout this row kat sini, dia adalah constant. In this case constant, keep it constant. Jangan apa ni, jangan jadikan dia jangan jadikan dia variable, dia lagi susah. Okay, sama juga dengan yang ni, dengan the height, the width in this delta Y. Sama juga sampai ke atas dia adalah constant. Tapi masalahnya, what's the problem? The problem is the height. Ketinggian dia. Sebab apa? Why? Because this height, this point is not the same. This point is not the same as this point. Okay, dia tak sama. Sebab tu, that's why I put X star dengan Y star. It depends on the point that you choose. Okay. So dalam case ni, fxy is not constant. Delta X, delta Y adalah constant, tapi dia punya height is not a constant. The same thing if you go back to one dimensional case, one variable case. Kalau tengok dekat sini, for one variable case, delta X is always the same. Okay, so it doesn't change. Does not change. Tapi fx star always change according to your curve. So yang ni fx fx lain, fx let's say 1 2 3. Dia tak sama dengan f of 1 and so on. Dia bergantung kepada curve fx. Okay. Okay, sebelum tu saya terlupa. Delta x definition dia apa? Delta x is the definition for b minus a over number of rectangle. So orang dapat dia punya width. Okay, dalam case ni, kalau pergi balik dekat sini, saya tak guna n. So I said in this case, let's say in x direction, and then in y direction, I have m elements. Apa maksudnya? So maksudnya kalau if I choose this is for box 1. So let's say this is delta A1. So this refers to coordinate x of 1 and then y of 1. Coordinate di sini. Okay, so maksudnya apa? Maksudnya x of 1 so dia akan pergi ke, so you will go to this point. How many x? This is from 1 to m. So dia akan pergi macam mana? Dia akan pergi ke x of 2, y1, x of 3, y1, and so on. So saya nak tunjukkan dia punya ni. So in X direction. So in Y direction, saya kata I have N elements. Same thing. So saya start from, this is A1 also, but the Y is changing from Y1. Let's say this is Y1, and then this is Y2 until 1 to N. Okay, so I have N number of elements. So just keep in mind. Okay, so let's say we evaluate from A to B. The region is from A to B, and then in Y direction, the region is from C to D. Okay, therefore, kalau saya nak cari, if I want to find the delta X sama juga yang tadi, cuma dia punya ni berbeza sikit, B minus A over M. So the width for each rectangle is B minus A over M, and the width in Y direction is just D minus C over N. Inclusive, yang ni adalah endpoint inclusive, dia bukan apa ni yang parenthesis, biarlah square bracket. Okay, so kita dah dapat definition untuk delta X and then delta Y. So delta X dengan delta Y sudah dapat. Alright, now how to find fx, y? How to find the height? So the height is given. Yang tu tak perlu risau. You will be given the equation for the surface equation. So kita dah dapat. So kita akan dapat f. Let's say I use f star. Sebab dia. So f star ni apa? F star is for f x of star and y star. Okay, so maksudnya apa ni sama ada saya nak ambil x coordinate ni. So f star is the height. Coordinate saya boleh ambil. Let's use another color. Okay, I can take this point as x star, y star. I can also take this point, or this point. So, and lastly, I can also take the middle point. Boleh, tak ada masalah. So, sebab tu saya buat star. You can refer to any point. It depends on what you want to do. The same thing for this guy, this first derivatives. First derivative. Singular integral, single variable. You can take x star, f star as this point, or this point, or maybe somewhere in the middle. Same thing for this one. You can take the right endpoint. Saya tersilap. Right endpoint or left endpoint, and then you can also take the average of this curve. Boleh tak? Sama juga dengan case yang macam ni. So it depends on you. So if you want to find what's the value for f star, you need to plug in the coordinate. Okay, so just plug in the coordinate. So this is the what? So this is the delta V. So that's one for one volume, one small box, one small rectangular area of rectangular. Okay, let's say I want to start daripada, I want to start from 1 until something. Okay, so I want to start from 1 until m in x direction, and then I want to start from 1 to n in y direction. So saya macam I need to sweep. So you sweep first in x direction, start from 1, and then you go up, added in y direction, and then after finish in y direction, let's go back to x direction and then go up. So you add everything up. So dalam kes ni kita ada summation of, so summation of, let's say start from j equals to 1 until n f of x star y star j. Kenapa saya letak j dulu? And then this is also j. And then delta x, delta y. Sorry, delta y. So delta x, delta y. So this is only in j direction. You need to also add in y direction, sorry, in I direction, which is I, and then I start from I equals to 1 until m. So yang ni pun, this is also we approximate. Why? Because the value for m and n are finite. Sama juga, if you want to make it exact, kita kena increase the value of m and n. Kita kena tambah lagi the value of m and n. For example, let's say I have this, kalau saya ada yang ni. Okay, I want to increase the, apa nama dia, dia punya precision, nak increase the precision, you need to divide more. Bahagi lagi. Divide in x direction. Looks messy. And then you can also increase in y direction. Increase the number of rectangle in y direction. Okay, and then you increase to make it more precise. So in that case, you let m goes to infinity, n goes to infinity. So you need, this is the definition for double integral. So limit m and n goes to infinity, double Riemann sum, I from 1 to m and j from 1 to n, f star, fx I j y I j star star and then delta a. Sebab apa? Sebab delta x, delta y, it's delta a. So it doesn't matter. Nanti kita tengok kenapa kadang-kadang, can you change the order? Let's say, boleh tak awak buat delta y dan delta x? Can you do something like that?
Can.
Boleh. Boleh, tak ada masalah. So you can interchange, but boleh tukar delta x, delta y ataupun delta y, delta x. It doesn't matter in integration. Tetapi dia akan melibatkan complication yang agak dia tengok difficulties lah. Kalau dalam rectangular dia tak ada masalah sebab dia punya difficulties tu kurang. Tetapi in other region may not be in rectangle, maybe some shape, dia shape any shape, bentuk yang tak apa-apa kadang-kadang. So benda tu akan menyebabkan sama ada susah atau senang. So it depends on your choice of delta x, delta y or delta y, delta x. It depends. But in most cases dia tak ada masalah. Okay, so that's why I put delta A. Sebab tu saya letak delta A sebab dia merujuk, you can interchange that. Okay, so this is the definition of double integral in region R, f, x, y, and then d, a. So this is the definition for double integration. So maksudnya apa? Double integration is the volume. Okay, R ni apa? R ni, this is the region that you want to set up. Awak nak set up region, is it a circle, is it a rectangular, or is it any geometry? It depends on your what you want to set up. So the problem, saya rasa awak tak ada masalah dalam integration, power integration, partial fraction, partial fraction, and then substitution. Yang tu saya rasa awak dah mahir dalam integration. The problem with double integration is your setup. Like I said, is it delta, is it dy dx or dx dy? It depends. So it will be more difficult if you choose the wrong order. All right. So definition dia apa? Definition dia. So the closed rectangle yang kita nak adalah, so R in this case is the rectangle. So this is just a region of A and B covered by C and D. So that's the region for this rectangle. Kalau awak ingat, so this is A and B, and then C to D in Y direction. Okay, so yang ni adalah, so this is the definition for coordinate X and Y in R2 real number, where X goes from A to B, and then Y goes from C to D. So kalau tengok dia adalah, in this case dia adalah inclusive. And then satu lagi peringatan, fxy is positive. Maksudnya apa? Maksudnya the curve, the plane is above the zero axis. So dia tidak cross the zero axis, dia bukan di bawah, dia bukan negatif. Okay. Contoh, kalau saya kata contoh. Examples. Estimate the volume under R equals to 0, 2, and then also 0, 2, below Z equals to 16 minus x squared minus 2y squared with 4 rectangles. Using upper right corner for each Rij. Okay, so kalau let's look at this one. You are given the value of function fx, xy, fxy, and equals to z, and with 4 rectangles using upper right corner for each Rij. Okay, dalam selalunya it's better if you want to draw the region first. Okay, sebab saya nak tengok macam mana benda tu, the position for each rectangle. So this is x and then this is y. And then dia kata apa? Dia kata region R is from 0 to 2. Let's look at 0. So this is, let's take this 1 and 2. This is 1 and 2. With 4 rectangles using upper right corner for each Rij. So kalau dia kata 4, so you have three method. Dia tak cakap four equal rectangles. Equal rectangle tu meaning square lah. Four rectangles maksudnya asalkan dia ada 4 rectangles. So you have 3 choices. One, you can put a square. Okay, this is another method, one method. Or another method, saya boleh buat, I can divide something like this. Okay, this is second method. This is the first, second, and then you can also put this division. Pun boleh. Sebab apa? Sebab dia tak specify what kind of rectangles. Dia cuma kata 4 rectangles sahaja. Okay, dalam kes ni rasanya which division, which rectangle that is preferred?
The first.
Yang ni. Sebab apa yang ni?
Sebab
Why you
zero,
choose the first one?
because dia kasih coordinate.
Apa dia?
Sebab dia kasih 0 to 2.
Zero apa? Tak dengar.
0, 2 times 0, 2.
0, 2 times 0. Okay. Kenapa? Satu, kalau awak tengok dekat sini, if you look at, dia macam, benda ni pun dia macam awak punya intuition. Apa, your gut feeling. Okay, if you look at this first rectangles, area yang ni, the area for the first rectangle, berapa nilai dia? What's the value for this height, apa ni? Yang apa ni saya buat ni? First rectangle. 1. 1 saja. Tapi kalau saya dalam kes yang kedua, second case, kalau saya buat macam ni, what's the value for this area? So kena nampak tak, awak kena kira sikit. Yang ni macam satu, yang ni adalah 0.5. So dia macam nampak tak dia nak dia tu dia ni sikit, walaupun nilai dia sama. Sebab apa? Sebab dia punya area benda yang sama. Sebab dia adalah jumlah tu akan dapat benda yang sama. So nampak tak awak ada macam ada tersekat sedikit bila nak buat macam tu. So dalam kes ni kita it's preferred that use square. Dan dalam apa ni, dalam calculus 1 pun awak dah dapatkan yang apa ni, dia punya optimum square is the optimum rectangle area. Awak dah pernah buat dalam apa ni, dalam calculus 1 hari tu. Okay, so tak apalah, kita disregard yang ni. So this kita tak nak, no, ini pun kita tak nak. Nampak macam tak adil. Alright, let's see this one. So kita dah bagi kepada yang ni, method yang ni. Dan dia kata with 4 rectangles, kita dah buat 4 rectangles yang region R from 0 to and 0 to kita dah draw, dah lukis. Upper right corner for each Rij. Okay, so this is the region R. Apa maksud upper right corner? So upper right corner for each Rij. What does it mean, Rij? So let's say this one, this is for R11, and then this is for R12, R21, R22. Okay. So upper right corner meaning for Rij, dia dekat sini. Untuk R11. So this is for R11. R21 corner dia di sini. R22. to 2, the corner is right here. And then this is for R1, 2. So dia ambil corner yang di sini. Okay, so maksudnya kita kena plug in the values. So kita kira dulu. Let's try to calculate, let's say the height first. Kita kira dia punya height. F of the first coordinate. Coordinate yang pertama. So let's say this is for R11. Koordinat dia apa? 1, 1. Right? So bukan dia sama dengan ni, dia adalah the first to what? And then R of 21. Sorry, saya tak nak pergi ke situ. Saya nak pergi ke atas dulu. I don't want to sweep in X direction, sweep in Y direction first. Alright. Okay, so R12 apa dia? And then after I finish in Y direction, I go back to R21. Apa dia? And then R22 is what? Okay, so saya masukkan setiap ni. So this is F. R12 is what? 1 and 2. This one. 1 and 2. The coordinate first. Sama dengan apa dia? Sama dengan apa dia? And then R21, coordinate dia apa dia? F of 21. 21 yang kat bawah ni. Apa dia, Fatin? Rectangle 2, 1. Koordinat dia apa?
F21.
2, 1, yes. Dia benda yang sama. 2, 1. And then F for 2, 2 is just 2, 2 as well. So berapa value dia? So mungkin awak boleh kira dulu. Guna apa dia? Nak guna mana? Nak guna Z equals to 16 minus X squared minus 2Y squared. So F11 berapa? So 16 tolak 1 tolak 2. So 16 tolak 3 jadi 13. Okay. And then R12 16 tolak 1 tolak dengan berapa tu? 4 jadi 10. Okay. And then R21 16 minus what? R12 bukan 10. Dia adalah 7. Apa dia?
7.
7 kan? 7. Okay. So yang ni baru 10. Saya tukar dia punya tu. And then R22 is 16 minus 8. Jadi 4. Okay. So yang ni arithmetic awak kira sendiri. And then the delta A. What is the delta A? Delta A awak dah kira tadi. Delta A for each is the same thing, which is 1. So the estimation for this area, the volume. So yang tu estimate. Sebab apa? Sebab yang ni dia cakap estimate the volume. So meaning estimate the volume, dia bukan exact, dia adalah approximate. So awak kena guna Riemann, double Riemann sum. Dalam kes ni, V estimate is just, you tulis dia punya definition from I from 1 to 2, J from 1 to 2. Sebab apa? Sebab dia ada 4 rectangles with 4 rectangles, tapi I dia start daripada 1 sampai 2, J start daripada 1 sampai 2. So ada total rectangle is 2 by 2 is 4. Okay, so this is just F X star Ij Y star Ij times delta A. So just summation, guna summation saja. So awak boleh buat apa dia, delta A darab dengan F11 tambah F12 tambah F21 tambah F. Di dalam kes ni koordinat tu dia sama dengan dia punya indeks. So tak baik sangat. Okay, so delta A dia apa? 1. So the thing is everything is just add up 13 tambah 7 tambah 10 tambah 4. So this is equals to
54.
34. So this is units cube. So this is the just estimation. Macam mana nak jadikan dia lagi precise? You need to divide more rectangles. Awak pernah belajar 3500 tak? MTH 3500.
Belum lagi.
Belum.
Okay, tak apalah. Sebab kalau awak belajar MTH 3500, awak boleh guna, ataupun mungkin siapa yang dah pernah guna apa ni, programming, you try to use for loop for something, awak akan for I from 1 until N, and then awak boleh guna for J 1 until N, and then awak boleh guna N ni mungkin sampai 100 ataupun ni pun sampai 100, boleh try ni. So dia akan increase dia punya ni. So yang ni dia tak tepat lagi. Okay, dalam kes ni, let's say, is it ada ni tak? Saya nak tanya sikit je. Does it matter if we took, let's say, saya dah ambil kes ni, saya dah ambil right end point ataupun right upper corner. Let's say I divide this into, this one. Okay, this is the rectangle. Mungkin saya boleh guna pembaris. Okay, ini sikit. Okay, kalau saya ada rectangles, and then I divide into same area, almost the same. Okay. Yang mula-mula sekali saya ambil, let's say I took upper right corner, same thing, took upper right corner in this case. Semuanya saya ambil upper right corner. So dalam calculus 1, awak belajar left end point, right end point, middle point, trapezoidal rule and so on. Awak belajar benda tu. Tapi sama juga dalam case yang double integration, mana-mana point yang awak pilih, bila awak as you take this point, the height ataupun the point f x star y star, x star dengan y star, Yang ni, it doesn't matter. Tak kisah. If n, goes to infinity and m goes to infinity. Sebab apa? Sebab bila saya divide more, let's say I use this one. So bila saya buat division lagi, so di area ni dia akan makin mengecil. So dia akan kecil sampai sampai point ni dia macam bounded. Dia ada, so macam nampak tak? Dia macam tak lari. Dia macam duduk dekat situ saja. Dia akan increase the precision. Dia akan increase the precision. So dia lama-lama dia akan kecil dari satu point saja. Dia punya tu dekat-dekat dengan macam satu titik. So dalam kes ni dia tak kisahlah awak nak ambil ni. Sebab apa? Sebab n will goes to infinity and m will also goes to infinity. Okay, kita ambil masa, let's take 5-minute breaks sampai pukul 12 kejap. Kemudian kita akan continue to use exact integral. Okay, take 5 minutes. Okay, thank you. Okay, so yang ni tak apalah, yang ni ada dalam memori awak yang tadi. Okay, the next one will be 4.2. Partial integration ataupun iterated integration. Okay, dia macam, tapi yang buat tajuk dia iterated lah. Apa maksud iterated? Iterated tu maksudnya dia buat sekali lagi. Buat kali pertama, kemudian buat kali kedua, kali ketiga dan sebagainya. Dia dia macam looping, dia macam berulang-ulang. Sekali, dua kali dan seterusnya. Itu maksudnya. So dalam kes ni, sebab kita ada 2 variables, so we just put 1 variables and then we do for another variables. Sebab tu nama lain bagi iterated integration is partial integration. So kalau awak ingat, if you remember from your partial derivatives, apa maksud partial derivatives? You differentiate one variable and then keep the other variable as constant. Okay, contoh kalau ada x kuasa 2y with respect differentiate with respect to y, with respect to x, it will be 2xy. Sebab apa? Sebab yang y itu you keep it as constant. Same thing for partial integration. For iterated integration, same thing for partial integration. Okay. For example, if I have this integration from C to D, so this is in y-axis, and then you have fx y dy. What does it mean? You need to take x as constant and then differentiate with respect to y from C to D. Contoh, examples. Differentiate from, let's say, 1 to 2, 2xy with respect to y. Okay, maksudnya apa? X ni adalah constant and 2 is also a constant. So meaning that you can just take 2x, 1, 2, and then y dy. So x is a constant, so boleh take out from the integration sebab you treat it as a constant. Same thing, for example, if you want to differentiate from A to B, fx y dx, so x run from A to B, you differentiate dx and y keep it as constant. we use the same example. Guna contoh yang sama. Let's say from 1 to 2, the function f xy is 2xy dx. So you can just take 2y and then 1 to 2x dx. So yang ni satu-satu. Okay, ada soalan ke? Okay, let's see. If we combine the whole thing. If we combine the whole thing, let me remind you that the region is still in AB cross CD. So X from A to B and Y from C to D. Okay, same thing kalau kita buat, let's say we have from region from this region. So kita combine yang atas tadi. So kita combine, integrate from C to D for fx, y, dy, and then you want to integrate from A to B in region in x direction. Okay, so apa saya buat? Saya boleh integrate yang di dalam tak nampak dia punya ni. So I need to integrate the inside first, and then awak boleh integrate the outside first. Or alhamdulillah. Or ataupun I can also do something like this. Sebab saya kata tadi, you can change dy dx or dx dy. You can also put from C to D in y, and then from A to B in x, fx, y, dx, dy. So in that case, apa kita buat? You took the inner integral first, okay, and then integrate, and then after that, do the iteration on the second variables. Okay. So bolehlah mana-mana. Yang ni tak ada masalah sangat. Okay, let's look at example. Evaluate this integral from x from 0 to 3, y from 1 to 2, x squared y, dy dx. Okay, so maksudnya apa? Maksudnya saya nak region saya, kalau saya lukis lah, kalau saya lukis dia punya region ni 0, 1, 2, 3 sampai sini saja. Okay. Oh, kenapa tak cantik sangat ni? Okay, sekejap. So rasanya baik buat koordinat dulu. So this is 0 and this is 1, 2, 3, and this is 1, 2. Okay, so maksudnya x from 0 to 3, so daripada sini ke sini, and then in y direction daripada 1 ke 2. So dia semua ambil yang kat sini saja, dia macam strip kat sini. Kenapa saya lukis? Sebab awak boleh nampak dia punya ni. Okay, maksudnya apa? Maksudnya saya nak fix x constant. So saya ambil constant kat mana nilai x. So let's say I put x in this case, and then I go through y axis. So this is fixed, and then go through. So x is fixed at this point. Dia datang, you came at 1 and then exit at 2. Same thing kalau saya letak kat sini, any point in this, so saya jumpa coordinate 1 and then exit at 2. So itu maksudnya. So saya fix saya punya base kat sini. Okay, so macam mana nak how to evaluate this? So you evaluate the inner part first. So you evaluate from 0 to 3. So X adalah constant, so you can take it out X2 from 1 to 2, Y dy, and then dx. So just put it into, so you can evaluate this first. Okay, apa nilai dia? Y dy. So mungkin ini nampak macam tak nak bagi messy, saya boleh cuma ni, this is separate problem. Separate this from 1 to 2 y dy. Nilai dia berapa? So dia akan jadi y squared over 2 from 1 to 2. So nilai dia berapa? 4 minus 1. Apa dia? Apa nilai dia? Lutfi, Zahir Lutfi. Apa nilai dia? Saya dengar macam ada suara tapi macam tak dengar sangat. Okay, over 2. Okay, so 3/2. So this is 3/2. Because why this is 4, 2 is 2 squared is 4, 4 minus 1 is 3. So 3 over 2. So the integration yang kat sini, this the value of this integration is 3 over 2. Okay, so saya masukkan balik. So I put it back into my integration. So 0 over 3. So V yang kita nak adalah 0 over 3, 3 over 2, x squared times 3 over 2 dx. So this is equals to 3 over 2 from 0 to 3, x squared dx. And this is just 3/2 times x cubed over 3 from 0 to 3. So dapat apa?
9.
9.
Okay. Oh, wait.
So this is x cubed
20.
over 2 from 0 to 3. Berapa?
13.5.
27.2. Okay, volume is unit. So unit cube. Saya lebih suka guna dalam bentuk fraction. Sebab jawapan dalam fraction. Sebab apa? Sebab dia ada exact, ada yang decimal ni. Contohnya kalau awak dapat 20 apa ni? Contohnya kalau saya dapat 25/3. For example, if I get 25 over 3. Dan kalau awak guna calculator, dia akan keluar apa? 1.8 point something. Dia tak habis. So kalau guna fraction, dia lagi exact. That's why I prefer to put into this form. Okay, dan kalau awak nak cuba pun, okay, let's try to another. Kalau saya tukar dia punya order, let's say I change the order. I use dx dy. Okay, let's try that one. So integrate from 1 to 2, from 0 to 3, x squared y dx dy. Okay, so first thing first, kita ambil yang inner part. yang inner kat sini. So kita kata this is equals to, so we let y macam tadi kalau tengok dekat apa ni, dekat picture tadi, this is the rectangle. So you choose y, fix y, and then sorry, this is the coordinate. Choose y and then run through x direction. So masuk dekat kosong, keluar dekat 3. Sama juga, it goes from 1 to 2, must choose from masuk daripada kosong sampai 3. So x is varies. So this is fixed and then x is varies. Okay, let's see this example. So start from 1 to 2. So y is now a constant. You can take it out. Y from 0 to 3 x squared dx dy. And then you work on this separate problem. You work on 0 to 3 x squared dx. So ni macam nak cari base area dulu. Alright, so this is just x, apa dia? X 3 over 3 from 0 to 3. So yang ni dapat dia apa? Apa jawapan dia ni?
Sembilan.
Okay, so jawapan dia 9. 9 unit square. So times, so if I want to put in this, so y times 9 dy, so this is just 9 times y squared over 2 from 1 to 2. So this is the volume for this guy. So 9 times 4 minus 1 over 2. So you get the same thing. 9 times 3 is 27 over 2. Ni nampak tak? Dia dapat jawapan yang sama. Sebab apa? Sebab yang ni rectangle dan dia tak kisahlah awak nak dx dy, dy dx. Okey. Ada soalan setakat ni?
Tak ada.
Tak ada eh? Okay. So kalau tak ada, let's look at this example. Let's say something like this. Fx dengan Fy ni, you can separate into Gx and Gy. Let's say Fx, Y, you can separate into Gxy times Hxy. So maksudnya awak boleh separatekan kepada dua function, satu function yang ni dan kepada satu function yang lain. Okey, kalau dalam kes ni dan pastikan fx ni adalah bounded. This is kena pastikan sikit, f is bounded in R. So maksudnya dia is defined on the boundaries. And then sekiranya if it's discontinuous, dia hanya discontinuous only on finite number. So maksudnya dia boleh dikira, dia bukan always discontinuous. It can be discontinuous but on some points. Yang tu pun tak apa, nanti kita tunjuk examples. So apa dia punya ni? Dia punya apa? Dia punya kelebihan dia kalau dalam kes ni. Kelebihan dia kalau dalam kes ni, if I have the volume, it's just the region in region R, fxy is the function, the space, sorry, the space, sorry, the surface, and the delta dA, saya ada AB, integrate from AB and then integrate from CD, fxy, dy, dx. This is the same thing if I put CD from A to B, fxy, evaluate x first and then dy first. Saya dah tunjukkan contoh yang tadi sebab apa? Kalau awak tengok dekat yang tadi, if you look at this examples yang kita tengok tadi, mana tadi contoh? Okay, let's see this one. If you look at this example, xy, this is fxy, is x squared y squared. Sorry, y saja. Okay, so if I want to separate into these two parts, this is the same thing as saya boleh buat yang this is just x squared times y. Let's see, does it define on x daripada 0 ke 2? Yes. Sebab apa? Sebab dia parabolic x. From 0 to 3 is defined. Tengok dekat y. Y, is it defined from 1 to 2? Yes, it defined because this is just a straight line. So sebab tu jawapan dia sama. Saya tukar dia punya order, dapat 27/2 and then I change into another one, I also get the same answer, 27/2. So apa nama benda ni? So this is called Fubini's theorem. Okay, so awak dia tak kisah nak interchange as long as f is bounded. Okay, ada soalan setakat ni?
Tak ada.
Ada. Okay, dan satu lagi, dia punya apa ni? Continuation from this part. The continuation of this Fubini's theorem. Let's say as long as you evaluate, dia dapat constant. Okay. Continuation daripada yang ni. So what, nampak tak dia punya ni? You can also put something like this. Continuation. Dia macam apa daripada formula ni? So if you put something like this, from, let's say from C to D, and then from A to B, fxy, dx, dy, okay, and then so saya pecahkan. So if I expand this C to D, A to B, yang ni akan jadi G x y, and then H x y, sorry, this is x, and then this is will be dx dy, and then it turned out that gxy is in function of x, and then h adalah function of y only. So for example, in this case, kalau tengok dekat sini, this case, this is g as function of x only, and then this case, h as function of y only. Okay, contoh yang sama juga, So if I put it into this form, saya akan dapat C to D from A to B, G of X, and then H of Y, dx, dy. Okay, dan saya keluarkan, I take out, boleh tak saya, apa ni, H ni, saya nak buang dia punya parenthesis sebab dia panjang sangat. Saya buat H sahaja. So I can take out the H. Saya buat CD H from A to B, G, dx, dy. Okay. Okay, kalau saya evaluate yang ni, output dia adakah dalam bentuk variables? I mean, is it going to be an X or is it going to be a number?
Number.
Number, meaning a constant, right? Number tu constant. Tak kisahlah nombor apa-apa, tapi dia adalah constant. So, apa dia? Apa dia? Siapa yang cakap?
Lupa off mic kot.
Awak tengah cakap dengan siapa tu? Okey. Okay. Apa ni, itulah apa ni kekurangan kita online ni. Saya tak tahu awak buat apa. Tapi saya mengharapkan kejujuran daripada awak semualah. Okey. Okey, bila dia constant maksudnya awak boleh take it out from the integration. Okay, so saya take out, saya boleh buat macam ni. So from A to B, G, saya tulis balik GX, dx times C to D, H of Y, dy. So remember that bila boleh buat macam ni bila when you can separate into function of single variable sahaja. Okay, so this is the V evaluated in R region, fxy dA. Okay, so ini adalah continuation from Fubini's theorem. As long as you can separate this variable. Kalau tengok contoh yang macam kita buat tadi. Okay, let's see this example. Nampak tak? Bila when you integrate this, akan dapat constant. This is a constant. Same thing kalau kita integrate yang ni juga, kita akan dapat constant. So this is the continuation. Likewise, kalau sama juga kalau saya dapat apa ni, kalau saya guna apa ni dy dx, maksudnya saya tukar dia punya interchange the variables, yang tu keluar yang tu ke dalam, saya akan dapat definition yang sama. So keep in mind that as long as fxy is g of x times h of y. So, awak boleh separate into that. Kalau tak boleh separate, tak boleh. Okay, contoh. Sebagai contoh, example. Ada soalan setakat ni? Okay, evaluate. Tak ada. Ada, tak ada?
Tak ada.
Okay. Evaluate integration from in our region for sine x cosine y dA, where r in 0 to pi half and 0 to pi half. Okay, so kalau tengok dalam kes ni, fxy, so this is the solution. Fxy is just sine x multiplied by cosine y. So if you want to integrate sine and cosine, awak dah expert dalam tu. Saya assume awak expert lah. Alright, so kita boleh buat. So this is just equals to, so v equals to integrate from 0 to pi over 2 sine x dx from 0 to pi over 2 cosine y dy. So jawapan dia apa? Tak perlu ni. So yang ni adalah 1, jawapan dia 1. Okay, ada soalan? Saya tak nak, sebab ini pun dia punya integration untuk sin x apa dia? Minus cosine, right? Minus cosine. Dia dapat 1. Yang ni integration for cosine is just sine. So you get 1. 1 times 1 is just 1. Okay. Let's see another examples. Let's see this one. Fx y equals to x minus 3y squared. And then I want to evaluate the fxy where r is in from 0 to 2. In region 1 to 2. Okay, dalam case ni, so let's look at this one. You cannot separate into g times h. Tak boleh nak separate. So if you cannot separate that, we still can use the iterated integration. So it's not a problem if you want to use this integration. Okay, let's see this. Is it boleh tak kita buat? Okay, let's see. Which one to use first? Okay, so kalau tengok kat sini, just plug in this value from 0. See, so from 0 to 2 in x-axis, from 1 to 2 in y-axis, x minus 3y cubed dy dx. Okay. Oh, dalam case ni boleh tak kita take out apa ni x tu? Dalam case ni tak boleh sebab apa? Sebab x ni dia minus, dia tak boleh nak factorize. Okay. So in that case we can just let it be inside. Dia aja dalam tu. Okay. Let's look at the region. So this is the coordinate 0 1 2. So this is 1 and 2. So x daripada 0 ke 2 dan ni pun sama juga dia punya region dia. So in that case, if you take y inside, so kita akan fix point x and then go through y. So fix, masuk, you enter in coordinate 1 exit at coordinate 2. Line. Okay, coordinate line. Okay, so in that case, boleh buat macam mana? So you can just put separate problem. You can take from 1 to 2, x minus 3y cubed dy. So just take this one first. So this, if you evaluate this, it will be x, y, sebab yang ni adalah constant, minus 3y cubed over 3 from 1 to 2. Okay, jawapan dia apa? Okay, tak apa, saya mungkin awak tak nampak lagi. So this is x, y is 2 minus 1. So you just, this is cancel out, minus 2 cube, and then minus 1 cube. Mungkin nampak confused. Okay, let's look at into this part. Okay, kita buat satu-satulah senang. Okay, so this is x, y minus y cube. So this means that x of 2 minus 2 cube minus dengan x of 1 minus 1 cube. Okay, yang tu baru nampak clear. Okay. Now, what's the value for this one?
X minus 7.
X minus
7.
7. Sebab yang ni 2 to the power of 3 is 8. 8 minus minus plus 1, 7. Okay, so in that case, plug in back from from 0 to 2, x minus 7 dx. X minus 7 dx. So yang ni adalah y. This is the value for this one is x minus 7. So x minus 7. This is easy. Power rule, x squared over 2 minus 7x from 0 to 2. So it will be, everything is 0. It's just, so 4 minus 14, this is minus 10. So does it make sense? The volume is minus 10.
No.
So from physical intuition, apa maksudnya? From physical intuition.
Below exists.
Apa dia?
Below 0 exists.
Yes, so it is below the XY plane. Same thing. So maksudnya awak faham lah maksudnya. Contohnya kalau kita ada negative area means it's below the Y positive, below the axis, positive axis. So it's below that. Same thing. So the volume in this case is just 10 unit cube. Okay. So because this is below XY positive plane. Kalau awak nak tengok dia punya surface pun memang surface dia di bawah, berada di bawah XY plane. Okey, ada soalan? Tak ada. Okey, so sebab apa yang tu straightforward, lebih kurang straightforward. Okey, next. So saya ulang sekali lagi, ada soalan? Kalau tak ada, saya nak recap balik kita punya ni hari ni. double integration over a rectangular region. So double integration ni merujuk kepada it refers to your volume. Because why? Because the volume is base area times the height. And then it comes from your double Riemann sum. When you divide everything into a small rectangle or small base, and then add up everything from 1 until infinity. So it will be a really big number of rectangles. So this is just the double Riemann sum is just an approximation. And if you want to have an exact value, you should take the limit. So this is the heart of calculus. Calculus is what you take the limit and you see the behavior of the value, the function. So you see that it always based on your definition of limits. And area under the rectangle, area under the surface. In this case, we only use rectangle. Rectangle is for x-axis, it's from A to B, and in y-axis, it's from C to D. As long as it is a positive. If it's negative, then it will be, like we did just now, it will be a negative values. Okay, and then how to draw the rectangle? It depends on your gut feeling. You want to draw same volume. You want to draw into a same area, or you want to draw into another types of area. It really depends on you. And the choices of your rectangle will determine the precision of your values. If you take this kind of corner, it will be different than if you take another kind of corner. Okay, and then this is for the F average, and then this is for iterated integration. What is iterated integration? You you integrate one by one. So you differentiate this, and then after you finish, you integrate this one, keep the other part constant, and then calculate that. After that, do it again for another variables. Okay, this is also will be applied, might be applied into another dimension. So in this case, we just 2D, only 2D. So you just, and then the good thing about this is if you can have fxy into two separate variables, and then you can just separate the double integration. It might not always be the case, but sometimes if you come across this kind of function, it is better to separate this. And the nice thing about area under the rectangular region is that you can interchange dx and dy. And if you interchange the order, the value of your volume is always the same. By what? By the Frobenius theorem. As long as f is bounded, and then only discontinuous at some point, not all points. What happens if it's discontinuous? If it's discontinuous, the same thing. Awak boleh, you can separate into the region. Macam the same thing, tapi kita tak sampai lagi kat situ. Awak boleh separate into two parts. Boleh separate, let's say from A to B. Awak boleh separate A to A to some A sub, and then A sub to B. So you can separate. Sebab apa? Sebab beza antara integration dengan derivative is that you can still integrate discontinuous function. Okay, that's the beauty of integration. For discontinuous function, you can integrate, but in derivative, you cannot differentiate discontinuous function. So saya harap awak dah, benda ni pun saya untuk peringatan, mungkin awak tak ingat, yang awak belajar dalam calculus 1. Okay, so That's the fundamental of calculus, the difference between those two. Okay. And then we do some examples. Okay, ada persoalan setakat ni? Okay, kalau tak ada, I just want to introduce the second part of this, or let's say 4.1.1.2, double integration over general region. Apa maksud general regions? Maksudnya dia tidak semestinya rectangular. It might be something like this. Ataupun something like this. Or what? Some kind of octagon, hexagon, something like that. So this is, it can be in any kind of shape. So kalau dalam case ni, if in this case, how do you want to approximate this area? Kita bercakap tentang area sahaja dulu. Okay, so in this case, for example, we start with summing the area first. So ingat lagi tak dalam sekolah dulu, dekat sekolah, awak buat macam mana dekat sekolah? So you divide, put it into on a graph paper, awak divide kepada beberapa bahagian. Let's say something like that. And then you say, okay, I want to pick only on the upper right corner. Saya ambil kat sini. Okay, dalam case ni, apa dia? Dalam case ni, kalau saya, if I want to calculate the area, oh ni macam tak adil. Ni ada banyak lagi lebih. Okay, let's do. If I want to calculate the area, apa saya buat? Okay. Saya cuma ambil mana-mana point yang ada tanda merah, even though it is on the boundaries. So in this case, apa yang saya nak highlight kat sini adalah dalam case ni, saya ambil, so this one I can take this one I can take, yang ni pun saya boleh ambil sebab apa? Sebab boundaries dia ada dekat upper right corner. Yang ni saya tak ambil, this one tak boleh sebab because the upper right corner is this part, tapi dia outside the boundaries. So yang ni boleh, yang ni okey, yang ni okey. Yang ni saya tak ambil, yang ni okey. So you then count how many tick marks. Saya lupa yang ni juga. So yang lain tu kita biarkan. So sama juga dalam case ni, kita guna benda yang sama. Okay, so this is for Riemann sum. Okay, how to do it for exact solution. Okay, dalam exact solution, persoalan yang saya nak tinggalkan dekat awak hari ini adalah, is it going to be the same? This fx, y, dx, dy over region R, is it going to be the same for the same region, fx, y, dy, dx? Okay, is it going to be the same? Itu persoalan dia. Okay, so kalau ada soalan boleh tinggalkan boleh tanya soalan. Kita berhenti setakat itu saja. InsyaAllah kita jumpa hari Jumaat. Okay, so sebelum tu saya terlupa. Minggu depan hari Rabu adalah cuti Wesak. Okay. Saya sebab apa? Sebab kalau boleh saya nak habiskan kita punya ni. Ada dia optional. Kalau awak nak ada kelas pun tak apa. Kalau sebab by default dia sepatutnya tak ada kelas. Tapi kalau nak ada kelas pun macam kita ada nanti dekat-dekat akhir tu kita ada free time sikit lah. Tak adalah ni sangat. So yang nanti dekat minggu ke-14 tu mungkin kita dah habis, kita boleh buat apa-apa yang macam revision ke apa. Okey, hari Rabu ni cuti umum, Wesak. Okey, ada siapa yang di sini nak datang kelas atau tak nak datang kelas? Mana nak letak?